Wow, that was difficult. So much to memorize. Oh my goodness. All right, so I'm going to do my best for you to kind of just go over the highlights here, but I definitely would spend some time with those slides trying to memorize everything because there is so much to memorize on this chapter. So, anyway, what this is about is hunger and satiety, and we'll just do the satiety factors simplified. So the first place where the food goes to is the mouth, and we do have some digestion there. You had that cool little digestion video. And then, but in the mouth, not only does it start digestion, but it actually starts your satiety. So I guess the Willy Wonka pill, where you take a pill and that makes your whole meal, that will probably not work. Because as they talked about in the textbook, is that people, when they would just do the sham feeding, pumping the food into their stomachs, uh, they pumped in about the same amount of calories that they should to maintain their weight, but they reported not feeling satisfied. So no food pills for us. So the next place where the satiety goes to is, well, digestive wise, it goes down the esophagus and then it goes down to the stomach. So there's no satiety factors in the esophagus, but the stomach. So the stomach, there's two main nerves that go from the stomach. It's the splanchnic nerve and the vagus nerve. So the splanchnic nerve, what it does is it kind of tells you the calorie content of what's going on in there, like how much, what is actually in there. So when you say, "Oh, this food is rich," it's probably activating your splanchnic nerve a lot. So you could say, "Oh, my splanchnic nerve is very activated." Just kidding. So anyway, that's why you can't drink a bunch of water. And yes, they do say drink water because the vagus nerve, it signals some stomach distension, which is a major, it has a major role in satiety. So stretching out your stomach is really important, but all of us know that when we drink a bunch of water and you're super hungry, your stomach is saying, "You know what? I am full. My stomach is full, but I know damn well there's no damn calories in there." So you've got these two nerves. The vagus nerve is stretch, and it tells you when the stomach is distended. And the splanchnic nerve will tell you how many calories is in there. And that's kind of interesting how, like, you can't really fool the stomach. It knows what you ate. All right. Then, after it sits in the stomach's kind of like a holding bill. There's not actually a lot of digestion that goes on there. It's kind of a mush maker. Then where it goes to is it goes to the small intestine, and that's the major place of digestion, actually. But there's also some satiety factors in there. So once the food enters the small intestine, it releases cholecystokinin, CCK. So when the CCK goes up to the brain, it will definitely signal satiety. So all these things are going on. You got your mouth that are saying, we're chewing something. You got your splanchnic nerve saying, yep, we got some calories in here. You got your vagus nerve that say, woo, we're getting distended. And then you got the small intestine releasing that CCK. And this all goes up to the brain. So let's go to the brain next. Oh, by the way, before I go on to this, another reason they do tell you to eat slow. And I would recommend eating slow because the less food that you eat before it enters the small intestine, the more likely you're going to get full faster. Not sure if that makes sense, but you guys should think about that. Okay. Whoops. We're going on to the brain. So we're going to look at 4 basic brain areas involved in hunger and satiety. And so the major hub is the arcuate nucleus. So that's getting all kinds of information into it about like the chewing. We've got the vagus nerve, the splanchnic nerve. We got this cholecystokinin, CCK. Then we've got these other hormones that we're going to talk about. Just got ghrelin. We've got insulin. Got all kinds of stuff going on into this arcuate nucleus. So the arcuate nucleus has a hunger center and it has a satiety center. So it's like the hub. And so everything feeds into there, and then it will send its messages to these 3 other parts. So let's see what's going on with these 3 other parts. So the lateral nucleus, it's kind of this area of the brain that says, go find some food, get active, go find some food, get some reward. And we're going to see that that one is affected by something called orexin. We're going to go on to the hormones on the next one. Then The ventromedial nucleus is kind of like a stop eating nucleus. This is an area where you eat at a certain time of day, and then it doesn't make you hungry in between meals. So what they find is animals with damage to the ventromedial nucleus is they're going to eat all day long. And that's another interesting, because when we're thinking about this, I have some slides and it talks about that around 30% of Americans now are obese, and I think a lot of us are watching our weight. Praise the Lord for some of you that just have that perfect body naturally, and you never have to watch your weight. But most of us are kind of considering what we're eating and influencing that. And something with this ventromedial nucleus to consider is this whole thing of, should you eat small meals throughout the day, or should you eat just 3 basic meals? And that's something that you could think about there. When you're eating small meals, you are keeping your stomach small, which is good. That's important. But you're also releasing insulin each time that you're eating the meals. And we talk about on the next slide how insulin is putting fat into can store the fat. So just some things to consider about this dieting advice and what's going on with the ventromedial nucleus, the paraventricular nucleus. So anyway, so we got the ventromedial nucleus. If you damage this, then the animal eats throughout the day constantly, just constantly. But if you were to damage the paraventricular nucleus, then what you're going to see is the animal will eat very large portions, very large meals. So these two seem to be more for satiety, and this one here is more for finding food. And then this is the hub for both getting all that information, how I talked to you about the satiety factors, and on the next slide we're going to go into the hormone factors. That's getting the information, and then it's kind of directing it to these places. Okay, now this is the tough one, and again, this is just a review, a quick review. I'm trying to go as fast as possible to make it really succinct, but you need to look at all the slides that I've gone over before. So your fat cells actually release a hormone to signal how much fat storage they have. And what's interesting is I don't know if you guys have noticed, but like when you don't eat right, you tend to get sick. It happens in my family with my kids. Like some of them cut their diets too much, or I cut my diet too much, and all of a sudden you'll feel like, oh, I'm starting to get some sickness here, because the leptin signals your fat storage to the brain, and it also sends messages to the immune system. Okay, ghrelin. I got a good way for you guys to remember this. My stomach is a ghrelin. It's not a growlin, it's a ghrelin. Okay, so ghrelin is the only hunger hormone. All the other stuff is kind of talking more about satiety, but this one is the only known hormone that we have right now that is saying we are hungry. So released by the stomach. The insulin, and of course the ghrelin is going to go up to that arcuate nucleus. Okay, insulin is a hormone that's released by the pancreas. And there's a whole discussion on there, and I think the diagrams and stuff look really good on that one. You should check it out in the PowerPoint ahead. But insulin, if you have a lot of glucose, then the pancreas releases insulin, because you got to have this homeostasis for how much glucose is in the blood. Also, your fat cells need that homeostasis, and so your fat cells like to be a certain size, and so when they start to shrink up, the fat cells are saying, oh, we're not happy, let's signal more hunger. And when they get too big, it'll say, oh, you've had enough, you're not as hungry anymore, everything's satisfied. So we've got this whole homeostasis thing that we've been talking about for thirst, for temperature, and we have it with hunger too. And this is why one of the reasons why losing weight is so difficult, and how your textbook talks about like most diets don't work, and that you should just make little changes and come up with small changes that you could maintain. So anyway, when your insulin is so high, then the insulin is, when the glucose is high, then the insulin goes in and it kind of will put away the glucose, so it gets it out of the blood. And then the opposite hormone released by the pancreas would be glucagon. And what happens is when your blood sugar goes low, then the glucagon will be released and it will take the stored glycogen and put it into the blood because the blood sugar has to be a certain level. We got to have that homeostasis. All right, CCKs, holistic canon. We already talked about this, that when the food is entered the duodenum or duodenum, people say it the same, different ways. Either way is fine. Is when that food enters the small intestine, the first portion of it, that's called the duodenum or duodenum. The CCK is released, and this will circulate up to the brain and signal satiety. Ooh, we have a new one. So neuropeptide Y, it blocks the satiety of the paraventricular center. So the paraventricular nucleus is supposed to say, oh, control meal size. So if this is released, then basically your meal size will go up because it's blocking that satiety. Okay, orexin is a chemical that is released in the lateral nucleus of the hypothalamus. And basically, what it does is it increases the animal's persistence for food and increases the persistence to get reward. So basically, this makes the animal more aroused. And so they talk about in the textbook that if these receptors are blocked, then the animal becomes very passive and doesn't seem to want to work for any food. So melanocortin is released by the arcuate nucleus to signal satiety to the paraventricular nucleus. So basically what this does is this stimulates the paraventricular nucleus and it says, control meal size. So if this is blocked, then what will happen is the animal will eat lots and lots more. So these are some hormones that are involved in eating. I know it's a lot to remember, but just see if you can focus on, this real simplified version.